shortest job first and priority based. In both of this algorithm, we have seen how this preemptive will work and how this non-preemptive will work. And then I ask you to find out the turnaround time for each of the problem. Have you found out the turnaround time?
Yes, sir.
Yes, sir.
Okay, good. If you have found out, then it's good. I'm not going to check. Okay, but if you found out, I'll be happy. So in those lines, today we have round robin, little bit complicated, but then not that tough. Slightly complex than the other scheduling algorithm, but it's very, very important scheduling algorithm in the process scheduling. Okay, please write heading as round robin scheduling. Round robin scheduling. Round robin scheduling is a CPU scheduling algorithm. Round robin scheduling. Iba, please join on time. Okay, it is already 6 minutes late, sir. Iba,
Yes, sir.
please join on time.
Okay.
Round robin scheduling is a CPU scheduling algorithm where each process is assigned a fixed time slot, in a cyclic way. Where each process is assigned a fixed time slot in a cyclic way. It is simple, easy to implement. It is simple, easy to implement. It is simple, easy to implement, and starvation free. As all the process get fair share of CPU. I'll repeat, it is simple, easy to implement, and starvation free. As all process get fair share of CPU. What is starvation? In general term, what is starvation?
When you don't get the food for a long time.
Yeah, you don't get your food for a long time, it is called as starvation. Similarly, when a process don't get a CPU, then we will call that process as a starvation process. So if the CPU is not allocated for the process for a long time, then we will say that process is under starvation. So I'm saying that this round robin scheduling will make the process starvation free. Why? Because for each and every process, we will allocate the CPU only for a certain period of time. Beyond a certain period of time, we will not allow the CPU. Okay, so that's how we can make the starvation free by using this round robin scheduling. Next point. Round robin scheduling is one of the most commonly used technique. Round robin scheduling is one of the most commonly used technique in CPU scheduling. Third point. It is preemptive. As processor assigned. It is preemptive as processor assigned CPU only for a fixed slice of a time. Only for a fixed slice of time. Obviously, it is preemptive, as I said. Whether the process is completed its job or not, we will not bother. The CPU will be allocated for the process only for a certain amount of time. The time will be unique for all process. Whether the process completed its execution or not completed its execution doesn't bother. Irrespective of process, whether it completes or not completed execution, the CPU will be forcefully removed from the process and it will be assigned to another process which is waiting in the queue. That fixed slice of time. Last point. The disadvantage of this round robin scheduling is more overhead is involved. More overhead is involved in context switching. More overhead is involved in context switching. More overhead is involved in context switching. So can we see a problem?
Yes, sir.
So listen carefully. It makes you confused, but then you have to listen carefully so that you can follow me. Wait, I will share the screen. Today my laptop is out of order. I am using my friend's laptop for the class. So it will take some time because I'm not used to this laptop. My laptop is under Windows update. Class,
Yes, sir.
Yes, sir.
please wait. You have to bear with me. Today I'm not using my laptop, so it will take time. Can you able to see the problem?
Yes, sir.
Yes, sir.
Yes, sir.
So in Microsoft Paint, can you able to see?
Yes, sir.
Please write the question, solve the scheduling algorithm using round robin, and then please write this problem. We have P1, P2, P3, P4, P5, P6, arrival time and the burst time. And the time quantum is 3 units. Please write the question and let me know, then we can proceed further.
Done, sir.
Done, sir.
Yes. Okay, there are 3 important steps that you have to follow while doing this round robin scheduling. Please write the 3 important steps. 3 important steps. First point. Within the job execution time, check for other process arrival. That's the first point. Within the job execution time, check for other process arrival. That's the first point. Second point. Add the newly arrived process in the queue. Add the newly arrived process in the queue. Add the newly arrived process in the queue. Third point, reduce the burst time. Reduce the burst time by the time quantum. Reduce the burst time by the time quantum. Reduce the burst time by time quantum. Fourth one, if the current job which is under execution, if the current job which is under execution, it's not completed its job, if the current job which is under execution, it's not finished, please write if the current job which is under execution is not finished, add the job at the end of the queue. Add the job at the end of the queue. Add the job to the end of the queue. Have you written all the 4 points?
Yes, sir.
Yes, sir.
Can anyone repeat the 4 points? Can anyone repeat the 4 points?
Within the job execution time, check for other process arrival. Second point is add the newly arrived process in the queue. Third point is reduce the burst time by the time quantum.
Okay.
And the fourth point is if the current job under execution is not finished, add the job at the end of the queue.
Perfect. Good. So look at the problem. So as usual, we know the graph will always start at 0. But check whether any job arrived at 0th time.
No, sir.
No, sir.
See, this laptop is making me mad. Yeah, 0. Yeah, we don't have any process arrived at 0, so we'll put this as idle. We have when is the first process arriving at? What time it is arriving?
1 second.
1. So until 0 to 1, we have CPU idle. So we cannot do anything here. So put the CPU idle. You can say it is idle. ID L E. CPU is idle, but we have a first time. What process is time 1? What process is being arrived?
P4.
P4. So we'll allocate P4 for the CPU. We'll allocate P4. And I said that each process will be allocated only a certain point of time. So here each process will be allocated only 3 units. So it starts at P3. Then add the newly added process in the queue. So I'm adding the newly added process in the queue. So P5 and P3 are added in the queue, right? Am I right?
So what about P2?
Then what is the third step? Reduce the time quantum. They reduce the burst time by the time quantum. So already what is the burst time for P4?
Nine seconds.
9. Already how many seconds that it has executed?
3.
So we have to reduce it. So from 9 it will become 6. So remaining is 6. Do you agree or not?
Yes, sir.
Remaining is 6. Remaining is 6. Next, what is the fourth point? Tell me the fourth point.
9 seconds.
Read the fourth point.
If the current job under execution is not finished at the job at the end of the queue.
If the current job is not finished.
4.
Kaushik Chiteri, read the fourth point.
If the current job under execution is not finished, add the job at the end of the queue.
Exactly. Check whether P4 is completed his job.
No, sir.
So we have to add it at the end of the queue. Current job is not finished its execution. So we have to add it at the end of the queue.
Sir, doesn't P2 contain in the queue?
What?
The P2 also arrives at 4th second.
P2 also arrives after the P3.
P5, P3. Yeah, P2 also. You didn't say.
Yeah, I said, sir, you didn't listen.
Oh, you said, then it is my mistake. I didn't listen. So we have to put all the jobs which is in the queue. Between 1 and 4, what are the jobs arrived? So 2 we have P5, 3 we have P3, and 4 we have P2. So all the things you have to write and add at the end of the queue. The fourth point, Kaushik, read the fourth point. Kaushik,
Yes, sir.
read the fourth point.
If the current job under execution is not finished, add the job at the end of the queue.
Yeah, check whether P4 is completed its execution.
No, sir.
So we have to add that job at the end of the queue. You have to add the job at the end of the queue. Until then, it is clear for you.
Yes, sir.
Yes, sir.
One second, please wait. Yeah. So now we will go with what is the next job in the queue. Please go to the queue. What we have next job in the queue?
P5.
P?
P5.
Exactly. So we will now take P5 in the queue. So I put the P5 in the queue. So P5, put that in the allocated CPU for P5. And what is the execution time of P5?
2.
2. But the time quantum is, what is the time quantum given?
3.
3. So we will not allocate 3 because the process required only 2. So we have to allocate the CPU only for the burst time. Even though the time quantum is larger than the burst time, we have to allocate the CPU for the process only for the burst time. So we need not allocate for 3. We can, if we allocate for only 2 seconds, it is enough. So P5 will be allocating only for 2 seconds because the burst time is only 2. So at 6, the process P5 will complete its execution. So what are the steps? Within the, again, you have to follow the 4 steps. Each one process when you're allocating CPU, you have to follow the 4 steps. What is the first step? Read out.
Within the job execution time, check for other process arrival.
Yes, what are the process which is being arrived? 4, 5, between 4 and 6, what are the process arrived?
P1 and P6.
P1, which is arrived at 5 seconds. So P1. What is the next process which is arrived?
P6.
P6. What is the second step? What is the third step?
Reduce the burst time by time quantum.
Yeah, P5 already 2 seconds we allocated. So this process is going to be 0 now. Am I right? So
Yes,
it is
sir.
0. What is the fourth step?
If the current job under execution is not finished, add the job at the end of the queue.
Yeah, but P5 is completed its execution, so we will not add at the end of the queue. We will not add because it completed its execution, so we will not add. Understood?
Yes, sir.
So what is the next job in the queue?
P3.
P3.
P3. So now we will allocate P3. So now we will allocate P3. So P3, how many seconds? What is the burst time for the P3? Is 7. So we'll allocate for 3 seconds. So it will be 9. Is there any job which is arrived between 6 and check again? Follow the 4 steps. Check whether any job is arrived between the execution time.
No.
No, sir.
No. So first 2 steps we will not do anything. Third step, reduce the burst time at the time quantum. What is the burst time of P3? It is 7. But we already allocated 3 units. So we have to reduce the burst time. So from 7 it will be reduced to, tell me,
4.
4. So we'll do that 4 correctly. Okay. From 7 it will be reduced to 4. Now what is the fourth step? What is the fourth step? What is the fourth step?
Give the current job under execution.
Why others will not open their mouth? What is the fourth step?
The current job is
If the current job is
and the next job will be other job at the end of the
No one is reading correctly. Please read that sentence.
If the current job under execution is not completed, add the job at the end of the queue.
Exactly. So P3, whether it is completed its execution.
No, sir.
P3, whether it is completed its execution.
No, sir.
So we have to add it at the end of the queue. So add it at the end of the queue. So it is now P3. Okay. So next job is that. What is the next job in the queue? We have to allocate CPU. Nothing but P2. Am I right?
Yes, sir.
Yes, sir.
So at P2, we allocate CPU for process P2. So what is the burst time for the P2? It's 6, but say time quantum is 3, so we'll allocate full time quantum. It will be nothing but 12. Am I right? So now again follow the fourth step. Check whether any process arrived between 9 and 12.
No, sir.
No, sir.
No, so first 2 steps we will skip. Third step, reduce the burst time by the time quantum. So P2 execution time is 6, but already 3 units we allocated. So now that burst time will become 3. Okay. And fourth step, what is the fourth step? If the current job is not finished its execution, add it to the end of the queue. So we have to add the P2 at the end of the queue. Understood?
Yes, sir.
Yes, sir.
So now my next job which is to be allocated, P4 has to be allocated. So I will allocate P4 now to the CPU. Again, you have to follow the 4 steps. So what is the P4 execution time? It's nothing but 6, right? 6 P4.
Yes, sir.
So now we can allocate 3 units. So it will be 15. And we have to check whether any jobs which is coming between 12 and 15. No, we don't have any jobs, so we have to skip the first 2 steps. Third step is that reduce the burst time at the time quantum. Yes, the burst time is now 6. We have to reduce it by 3. And we have to check whether the P4 completed its execution. No, P4 is not completed execution, so we have to add again at the end of the queue. So we have to add P4 at the end of the queue. So now we have again process P1, right? Am I right?
Yes, sir.
Yes,
So we'll
sir.
add P1, we'll allocate CPU for the process P1. And P1 burst time is 5, so we'll allocate 3 time quantum, which is nothing but 18. So between 15 and 18, we have any process? We don't have any process. So first two steps we will skip. So third step is that we will reduce the P1 execution burst time by 3 because we already allocated. So remaining will be 2. And the P1 is not completed its execution. So we'll add the P1 at the end of the queue. We'll add P1 at the end of the queue. The next job which is allocated for CPU is nothing but P6, right? After P1 we have P6, so we'll allocate P6 for the CPU. We'll allocate CPU for process P6. What is the P6 execution time is 3. So we will allocate 3 units. The time quantum only we have to allocate. We cannot allocate more than time quantum. So if 3 units is allocated, it will become 21. And we have to check whether between 18 and 21 any processes are right. We don't have any process arrived. So we will skip the first 2 steps. Third step is that reduce the time quantum. So P6 already 3 is there. We allocated 3 units now. So P6 is completed its execution. So we fully allocated the required time for process P6. Fourth step, the current job is not finished its execution, but P6 is finished its execution. So we will not add at the end of the queue. Do you agree with me?
Yes, sir.
So now we have which process in the queue? We have now P3 process in the queue. So we'll allocate now P3. Now we allocate the process P3. Again for process P3, how many? What is the execution time for the process P3?
4.
What is the remaining execution
4.
time in the process P3? 4. But we can allocate a 3 time quantum. So it is nothing but 24. You have to check again the same 4 steps. Between 21 and 24, any process arrived? No. So you have to keep the first 2 steps. Third step is to reduce the burst time and the time quantum. So the 4 will be now allocated to, reduced to 1. Do you agree with me?
Yes, sir.
So now check whether P3 is completed its execution. No, P3 doesn't complete its execution.
No.
We have still 1 units left. So you have to add it at the end of the queue. So it is nothing but last we have to add it at P3. Okay, understood or not?
Yes, sir.
sir.
So now we have what is the next process in the queue? We have P2. So we'll allocate P2 for the process here. What is the execution time of the P2 now? 3 units. So we can allocate the full time quantum here. So if we allocate the full time quantum, it is nothing but 27. So it is nothing but 27. So between 24 and 27, we have to check whether any process arrived. We don't have any process arrived. So we can skip the first 2 steps. Third step is reduce the burst time by the time quantum. Yeah, burst time is 3. If you reduce the 3 allocated time, it will become 0. What is the fourth step? We have to check whether P2 completed its execution. Yes, P2 completed its execution. So we will not add at the end of the queue. Do you are getting me?
Yes, sir.
Okay, what is the next job in the queue?
P4.
P4.
P?
P4.
P4. P4. What is the burst time for the P4 now?
3.
3.
3. So we can allocate the time quantum. So it will become 30. So again, follow the 3 steps. We have to check whether any jobs are right between 27 and 30. No, we don't have any jobs. Let us skip the first 2 steps. Third step is that reduce the burst time by the time quantum. Okay. So what is the burst time for the time quantum? If we 3 units, we already allocated 3 units, so remaining job is 0. So we have to check now whether P4 is completed its execution. P4 completed its execution or not.
Completed.
Yes, sir.
So we will not add at the end of the queue. Okay. Okay. Now what is the next job in the queue?
P1.
P1.
So allocate P1 to the CPU. And what is the burst time for the CPU now?
2.
2. So we need not allocate 3 units. We can allocate only 2 units. So after allocating 2 units, the time will be 32. So again, we have to follow the 4 steps. Check whether any jobs are right between 30 and 32. We don't have any jobs. So we can skip the first 2 steps. Third step is that reduce the burst time at the time quantum. So what is the time quantum allocated here? 2 units we allocated. So 2 minus 2 will be 0 here. So now 4th step, we have to check whether the process completed its execution. Yes, P1 completed its execution. So we will not add at the end of the queue. So what is the last job in the queue?
P3.
P3. P3. So P3, what is the execution time? Now left burst time? 1 unit. So we need not allocate 3 units. We can allocate only 1 unit. And if we allocate 1 unit, it will become 33. So what is the next? Again, we have to follow the 4 steps. We have to check whether any jobs are between 32 and 33. No jobs. So first 2 steps you have to skip. Third step is to reduce the burst time by the time quantum. So we allocated only 1 unit. So 1 minus 1 will become 0. Then we have to check whether process P3 is completed its execution. Yes, process P3 completed its execution. So we will not add at the end of the queue. And we have no other jobs left. So the Gantt chart ends. Have you understood now?
Yes, sir.
This is how the round robin schedule work. And this is very predominantly asked questions in the gate and the net. Not the same problem, but concept is same. There are many minute aspects. They will confuse you and they will ask questions in this concept. They will ask you question for sure in the get net and the gate examination. Understood?
Yes, sir.
Yes, sir.
Any doubts? Any doubts?
No, sir.
No, sir.
If there are no other doubts, calculate the waiting time for all the process and calculate the turnaround time for all the process. Calculate the waiting time and calculate the turnaround time. Can I calculate? Class, you are calculating, right?
Yes, sir.
Okay, please calculate. Have you done? Class,
Yes, sir.
have completed?
Yes, sir.
Can I ask questions?
Yes, sir.
So, Ajanya. Ajanya. Ajanya.
Yes.
Waiting time for process P1. See, whenever I ask question, Jugirani will go and then Srilata Vaditya will go. This is happening from the first semester. Whenever question is asked, either of them will leave. Zugirani and Srilata Vaditya, the first persons will leave and never ask questions. Okay, I'm not bothered. This is your life, your marks. So tell me, Ajanya,
22, sir.
22, okay. Anvish,
Yes, sir.
what is the waiting time for process P3?
23, sir.
Okay, perfect. Shahana Shirin. Shahana Shirin.
Yes, sir.
P2, what is the waiting time? Shahana Shirin.
Yes, sir. It's wrong, sir. I did wrong.
No, you tell me the answer. I never said the answer. I'm asking what is your answer. P2 waiting time.
50.
Huh?
50.
Tell me, Shahana.
50.
Type in the chat box. Shahana, please type in the chat box. P2, what is the waiting time? Wrong, it's wrong. அப்பா கிளாஸ் எடுக்கிறேன் நீ போ அப்புறமேல் வாங்க போங்க குட் கால் தானே போங்க Nicholas P, what is the waiting time for process P2?
17, sir.
Yeah, 17, perfect. P4, what is the waiting time? Iba Cleopatra. P4, what is the waiting time?
29.
Iba,
So I got 29.
what is the waiting time? Type in the chat box. Iba,
Yes, sir.
20, yeah, perfect, 20. Waiting time for P4 is 20. So what is the waiting time for P5? Sriram SG?
2, sir.
Perfect. So what is the waiting time of P6? Wait, I will just check who was to answer. Shivalila, waiting time for process P6. Andagula Shivalila,
Yes, sir.
what is the waiting time for process P6?
3, sir.
Huh? P6 waiting time. Andagula Shivalila,
Yes, sir.
tell me the answer. What answer are you getting?
3, sir.
Wrong. Sushmini Kumar, waiting time for process P6. 12, yeah, perfect. Sushmini, perfect. It's 12 actually. So now calculate the turnaround time for all the process P1 to P6. Calculate the turnaround time. Calculate the turnaround time.
Done, sir.
2 minutes time. So now the time is 11:01. 11:03 will ask you questions. What is the turnaround time for a process P1 to P6? Please calculate. So turnaround time have we calculated?
Yes, sir.
Yes, sir.
So what is the turnaround time formula?
Completion time minus arrival time, sir.
Perfect. So can I ask Deepansh Dimman, what is the turnaround time for process P1? Deepnas Dimman,
Yes, sir.
turnaround time for process P1, please.
The
P1,
28.
please.
Sir, 28.
No, wrong. No. P1, what is the turnaround time? Deepnas Dimman? Niranjana?
Sir, 5, I don't know, sir.
You know what?
Sir, for the second one, the arrival, have to find out the arrival time, sir. Like, is it 30?
I asked turnaround time. What is the formula for turnaround time?
Completion minus arrival time.
Okay. So you know the completion
But in
time
the
from the Gantt
queue-
chart. You know the arrival time from the given problem. So tell me the turnaround time for process P1. Don't know is not the correct answer.
Sir, like, I got 5, but I know it's wrong.
What is the answer for P1 turnaround time? Niranjana, just apply the formula, Niranjana.
Sir, 18 minus 5 plus 32 minus
18.
30.
Where comes the 18? What is the completion time
No,
of
sir.
process
I
P1?
just said the formula, sir.
You have whether you have drawn the Gantt chart along with me while I'm discussing
Yes.
the problem.
Yes, sir.
Check in the Gantt chart what time the process P1 completes its execution.
18.
18. When it is complete its execution, go through the Gantt chart properly. Go through the entire Gantt chart. Process P1, when does it complete its execution? You have to
Like the entire P1.
yeah,
32?
entire when it is completed its execution, you have to go to the entire Gantt chart. Tell me and when it is completing its execution.
32.
Okay, what is the arrival time?
5.
So 32 minus 5,
18.
18.
Sorry, 17. 17, sir.
17.
Sorry,
Niranjana,
27.
I want to teach you mathematics, Niranjana.
No, sorry, sir. I was nervous, sir. 27. 27.
What, Niranjana? You were in half sleep or what?
No, sir. I was nervous, sir.
27. Okay. You be alert.
Yeah.
You cannot be sleepy in the class, in the morning class, that too.
Sorry, sir. Yes, sir.
Tatula Shweta, what is the waiting turnaround time for process P2?
20.
P2, what is the turnaround time?
23, sir.
Huh?
23, sir.
Tatula Shweta? Perfect.
23, sir.
Divyasti Raghu, P3 turnaround time. Yeah, correct. Divyasti P3 turnaround time.
30, sir.
Hari, P4 turnaround time.
29.
Sagana, P5 turnaround time.
P 24.
Sagana,
24.
24. Ah.
P5 or P4, sir?
P5 turnaround time.
Four, sir.
4, perfect. Kaushik, P6 turnaround time. Kaushik Chiteri,
So 15,
P6 turnaround time.
15, sir.
15, perfect. So this is how we have to work on the problem. Now I will give one more problem as assignment. You please work on the problem and tomorrow we'll discuss the same. And by this I have discussed all the algorithm which is there given for the project. So you can start the coding right now with your teammates. Don't think there are 6-7 weeks ahead. Now those weeks and all will fly away like anything. So you have to start working from today for all these algorithms. Any doubts you have in implementation, you have to contact me. Okay, so try to do the coding by yourself, which will enhance your problem understanding, implementation. It will enhance your skills actually. So don't copy or don't seek any of your seniors or from the internet help. That will not help you out. This is not for marks. Okay, mark is nothing actually. Okay, you have to gain experience on this live project. That is what the ultimate objective. So please do the code by yourself and please note down the assignment problem. Class, you are there?
Yes, sir.
Yes, sir.
Yes, sir.
Can you able to see the screen?
Yes, sir.
Yes, sir.
Yes, sir.
Please wait. This is not a problem. I will just delete. Yeah. Arrival time is 0, 1, 2, 1, 2, 3, 4. Burst time is 5, 3, 1, 2, 3. 5, 3, 1, 2, 3. And the time quantum is 2 units. Please write this question and you have to solve using round robin. P1 to P5, 0, 1, 2, 3, 4, 5, 3, 1, 2, 3. Solve the above by using the round robin scheduling algorithm. You have to just follow literally the 4 steps which are given and you have to solve. Very, very easy. Any doubts?
No, sir.
Have you copied the question?
Done, sir.
Yes, sir.
All of you?
Yes, sir.
Yes, sir.
Okay. So tomorrow, before coming for the class, make sure that you complete the Gantt chart. You have to say me the average waiting time and average turnaround time. Okay, average waiting time and average turnaround time, and the Gantt chart you have to show, and I will ask you to project. Any people will ask you to project the same thing. Okay.
Okay, sir.
Any doubts?
Yeah. Sir, when we calculate the turnaround time, why do we use the arrival time on the queue, sir?
See, turnaround time is nothing but process when it is arrived, when it is completed. That is what the turnaround time. That is what the formula.
We first put the most of them in the queue, sir.
Okay.
So why do we use that arrival time instead of the arrival time that we use for processing?
See, what is your question? I'm not getting, Adi Krishna. Can you please elaborate?
Should we take the arrival time that is given in the question, or should we take the arrival time that is drawn in the Gantt chart, sir?
Yes, sir.
Arrival time always you have to go through the question only. You cannot go through the Gantt chart. See, process might have arrived very early, but in the Gantt chart using round robin, you can allocate it at very later stage. That is not an issue. For only completion time, you have to look at the Gantt chart. Arrival time always you have to look at the question. Turnaround time is nothing but when it is arrived, when it is completed. That is called turnaround time. The difference between the completion time and the arrival time. The arrival time you have to only look in the question. It may arrive at 0th second, but you may allocate CPU only at the 10th second. That does not matter. You have to check only the arrival time of the process initially waiting for the CPU allocation. That time only you have to check.
Okay, sir. Okay.
Any other doubts?
No, sir.
So please work out this problem and we will meet tomorrow. Thank you. Please give the attendance. Thank you.
Thank you, sir.
Thank you, sir.